Here is an example of a sentence scoring criteria for one sentence. Here's an example of the sentence scoring criteria for one sentence. For aphasia, here's an example of the sentence of the scoring criteria for one sentence. For both aphasia and bilingualism-induced errors, they were counted on a score from 0 to 5. For aphasia, errors were classified into 5 categories as denoted by Butterworth and Howard. The 5 categories were open class lexical errors, closed class lexical errors, inflectional affix errors, constructional errors, and 5 as other. Common mistakes, often denoted as this last category, were aphasia-induced word swaps and neologism, when individuals either say a related word similar to the target word or create a new one that isn't English. For example, this sentence, the word surface is For example, this sentence receives a 2 out of 5 on the aphasia error calculation because the words are out of order and the word surface is said incorrectly. For bilingualism-induced errors, this sentence receives, for BE, or bilingualism-induced errors, it receives a 1 out of 5 because of the incorrect subject-verb agreement. The 5 error categories for BE were Spanish influence, subject-verb agreement, article error, preposition error, and other. Word count, sentence content, sentence completion, and sentence complexity were also recorded. If an error fit in both an aphasia and bilingual category, they were counted in both. Each sentence was recorded for the presence of errors and individual statistics about both of them. Data about each of the patients for each of the sentences and data for each of the patients and each of their sentences was compiled and uploaded into an Excel sheet, and data from all 15 patients with each sentence was compiled to an Excel file and then uploaded to RStudio. RStudio was then used for statistical computing and analysis related to how different factors changed over the course of treatment and their relevance. In my statistical analysis, I used RStudio, including a proportions test, an ANOVA regression model, and a mixed effects model, In my statistical analysis, I used RStudio, including a proportions test, an ANOVA regression model, and a mixed effects model, which controlled for byword and biparent variation, the natural variation in each patient. For analysis, I used RStudio, a proportions test, an ANOVA regression model, and a mixed effects model. This controlled for byword and by-patient variation, which is natural from word to word and from patient to patient. Here's a photo of some of the code that I used as part of RStudio to complete the graphs as well as the statistical analysis. The 2 main results were most important. Here we have shown AE total over treatment and BE total over treatment. Here, we have the most two important graphs for the results. On the left, we have AE total over treatment and BE total over treatment on the right. Here, we have the most two important graphs for our results. On the left, AE total over treatment, and on the right, BE total over treatment. For the left, it's important to note that as treatment time goes on, the AE total, or total number of aphasia-related errors, decreased over time. On the right, BE total over treatment remains about the same, as the results were scattered throughout treatment time. Here are the collective graphs of AE total over time for each individual patient. Here's the same for the BE total over time for each individual patient. As you can see, it is more scattered in the BE individual. In addition to calculating the total aphasia errors, as well as the total bilingual errors, word count over time was also calculated. However, this resulted in an insignificant p-value and therefore should be discluded from the study. In addition to calculating the aphasia errors and the bilingual errors, the word count over time was also collected. However, this had an insignificant p-value. Also, sentence completion was also accounted for. The results showed that after each additional treatment, results showed that as time went on, patients had more and more complete sentences, which is statistically significant. However, sentence content had no specific relations. Now, why are these results so important? While also confirming the treatment's proficiency in treating aphasia, results confirm that this study's separate content analysis of specific sentence errors is an accurate way of separating aphasia errors and bilingual errors. Because the aphasia errors decreased over treatment time and bilingual errors remained the same, this matched our hypothesis. Because patients were being treated for aphasia and not for their English proficiency, because patients were being treated for their aphasia and not for their English proficiency, it would be expected that aphasia errors decrease over time. However, because their Spanish and English abilities are remaining the same, the bilingual errors should be remaining stable. The differences in these two charts are important because they indicate that the separation of aphasia errors and bilingual errors as created in this study using the novel scoring system was an effective way of separating them. Sentence completion results also reveal that the larger ongoing study is a reliable source of aphasia treatment and can be relied on. This is because as aphasia treatment went on, the sentences became more and more complete. This study may also provide a specific scoring system for Spanish and English. This study may also provide a specific scoring system for Spanish and English bilingual aphasia treatment, and also may reveal patterns about sentence content over treatment time. In the future research, I'd like to expand my dataset to over 50+ subjects, as well as look at grammatical factors in relation to each type of aphasia. I'd also like to investigate word count and how it's different in Wernicke's versus Broca's aphasia, which may have affected this study. How can the scoring system become more accurate? Finally, I'd like to relate sentence structure and the errors to other bilingual aphasia factors. Because I only looked at aphasia errors and bilingual errors, I'd also like to look at the effect of age of acquisition of. I'd also like to relate sentence structure and errors to other bilingual aphasia factors. Because I only looked at aphasia errors and bilingual errors, I'd also like to look at how the age of acquisition, the language 1 versus language 2, and the stroke type, and how they affect the language. And how they affect the language proficiency. And how they affect bilingual errors. And how they affect language proficiency. Finally, in the future, I'd love to add a scoring system to. Finally, in the future, it would also be beneficial to add a scoring system to a machine learning type system to personalize and account for each patient's language history and stroke type. Here's my bibliography. And here's my final slide. Thank you for watching.